Hello guys, welcome to Sunya IAS. So today we are here in the last video of the series of CSAT PYQ discussion, and today also we will be discussing the topic of miscellaneous category, those questions which cannot be categorized in a particular chapter. And so today we are going to see three types of questions. The first questions are those which involve the idea of sequence and series. There is one question then which involves the idea of SI and CI, which is simple interest and compound interest. And finally we have three more questions which are further in the miscellaneous. They are miscellaneous squared. I mean, they cannot even be further categorized into the miscellaneous subcategory. So those questions are quite off the wall, but we will see those questions one after the another. And so on that note, we will begin our discussion. So as you can see, we are completing comprehensively all the topics which are required. So that sequence and series, the topic I just talked about, and also simple interest and compound interest has been discussed about exhaustively here in our online course, as you can see. So further we'll move on to the questions now. The question says this, but before that we'll talk about the basics of arithmetic progression. Okay, so here in sequence and series we talk about two kinds of series. The first one is arithmetic progression, which is simply called AP. What is AP? In AP you have, there is a first term, some initial term, let's call it to be 3, and then further in each term you just keep adding a constant value. That constant value is called common difference, denoted by D. So the second term will be A plus D, A plus 2D, A plus 3D, and so on. So here you can see that if the first term you take as 3 and you keep adding 4, you will get 7. Further you add 4, you get 11. Further you add 4, you get 15, and so on. Right? So what is 3? 3 is basically 3. 7 is nothing but 3 plus 4, which is the common difference. 11 is nothing but 3 plus, just a minute, we have 3 plus 2 times 4. Here we have 3 plus 3 times 4. So as you can see, if we talk about the first term, if this is the first term, let's call it T1, it is simply equal to A. When we talk about T2, it is simply A plus D. So if there is 2, A will be multiplied with 1 only. Similarly, we have the third term T3 here, it has 3 plus 2 into 4. So since we are having third term, we are multiplying the common difference by 2. Similarly, here also when we talk about T4, we have 3 plus 3 into 4. Here the 3 signifies one term less than 4. So if simply someone asks from you that what is the value of Tn, that will be simply the first term plus 1 less, that is instead of n there will be n minus 1 multiplied by the common difference. Okay, that is the nth term of an AP. Any random term of an arithmetic progression you can find out by just knowing the concept 1 less. Okay, and further if you want to find out the sum of all the terms in an AP, the sum of terms in an AP of all these terms you are there, if you want to find the sum of them, the idea is simply n by 2 into T1 plus T last. Okay, so if you want to find the sum of the terms in an AP, just have the first term, which is 3 here, the last term, suppose you are having the last term as Tn, so Tn will be simply A plus n minus 1D, just put that value T last, and multiplied by the number of terms. So suppose you are having 10 terms, multiply by 10 divided by 2. This is the basic formula that will be required to find the sum of terms in an AP. Now look at the questions now. A contractor has a penalty of rupees 200 on the first day, 250 on the second day, 300 on the third day, and so on. So the idea is each succeeding day there is rupees 50 more penalty than the previous day. This is what it is saying. So how much penalty should the contractor pay if he delays the work by 10 days. So you have to pay the penalty for 10 days. So let us see the idea first. What is the penalty? So the penalty is that for the first day it is 200. For the second day it becomes 250. For day 3 it becomes 300. So overall you can see there is an addition of 50 and so on. What about the 10th day? On day 10, what will be the penalty amount? So simply you can say on day 10, here the number of term will be 10. You can say the amount is how much? A plus n minus 1d, the penalty for the 10th day. This is the T10 that we have to find, right? As you can see, it is simply an arithmetic progression. Here the first term is nothing but 200, and also the common difference, each term is getting added by 50, the common difference becomes 50. So this is basically an arithmetic progression. Here the 10th term you can find out as simply a, which is equal to 200, plus you have n minus 1, 10 minus 1 will be simply 9, into d, which is 50. So you get the overall amount as 200 plus 450, that is rupees 650. Okay, this is the penalty for the 10th day. Now please, in a hurry, do not take this particular option, because that is not the final answer. This is the penalty on the 10th day. We want to find the penalty for all these particular days from day 1 to day 10. So what we have to do, we have to just find the penalty for day 1 plus day 2 plus and so on till day 10. We have to just add up all the penalties. That is, we have to find the sum of this arithmetic progression. And you know the idea of finding the sum of the progression. You have a simple formula which says sum of an AP is equal to n by 2 a plus the last term, I am writing it like L, right? T1 plus T last I wrote, I am just simply writing it. T1 will be a and T last will be this 650. So what are the total number of terms? There are total 10 days or 10 number of terms, divided by 2. First term is 200, plus we have the last term as 650. Just add all of them up. You can cancel it out. You have 5 into, when you add these two you get 850. Now just multiply. So you will get the value of, I guess, 4250 rupees as the overall amount of penalty. That is, option number B will be the correct option in this case. So here we have the idea of arithmetic progression. Now in the second question and the third question, we will talk about the idea of the second kind of series, which is geometric progression. So in a geometric progression, the basic idea is that there is a first term and then the terms get multiplied by a constant number each time. So let us assume the constant number to be R, which is called as the common ratio. So the first term is this, the second term is AR, then we will have the third term as AR square, fourth term as AR cube and so on. This is T4 and so on, we will get the terms. So simply let us take an example. If the first term is equal to 1 and we keep multiplying each term with 1 by 2, here we will get 1 into 1 by 2, that is 1 by 2. Then further multiplied with 1 by 2, you will get 1 by 4, then 1 by 8 and so on. Such a series is called a geometric progression. Okay, so there are a lot of formulas there, but we will not discuss them. We will just see how the questions can be solved. So let us focus on this part now. It says that if there is a policy that 1/3 of the population of a community migrates every year from one place to the another, then what is the leftover population of that community after the 6th year if there is no further growth of the population? Okay, so suppose the question says that you have some population, let's assume the population to be P. Out of it, the policy is that 1/3 of the people are migrating every year. So 1/3 are migrating. So if 1/3 are migrating, how many are staying there? How many are left? The leftover population is obviously 2/3. These are the people who are left. So this is about 1 year. So if we are talking about 1 year, in 1 year the migration will be such that the migratory population will be P by 3 and the population left over will be 2 times P by 3, right? This is for the year 1, and the same pattern will be followed for the 6th year. So let me just draw a diagram that will make things very easy for you. So let's say we have total population is P. In year 1 only 2/3 is left, so we get 2 by 3 P which is left. In the next year, further year 2, out of this population, remaining population, 1/3 will migrate but 2/3 will stay there. You will have 2 by 3 of P, that is nothing but 2 by 3 squared of P. Further in the year 3 you will have only 2/3 of this population further staying, so we will have 2 by 3 cube P. So as you can see, if year is year 1, you have 2 by 3 to the power of 1. Here you have year as 2, you have 2 by 3 to the power of 2. For year 3 it is 2 by 3 to the power of 3. So you can simply understand that in 6 years, so during the 6th year, the population left over will be 2 by 3 to the power of 6 P. And that is what he is asking you. He is asking you that if there is no further growth in the population, what is the leftover population? So if we are assuming the total population to be P, in 6 years only 2 by 3 to the power of 6 P is remaining. So what is the leftover population? That is simply 2 to the power of 6 by 3 to the power of 6. It becomes 64 divided by 729. Right? So 64 by 729th part of the population will be left in the community. So this question is actually having the basic idea of a geometric progression. So each year the population left will be like this. Let me show you in terms of GP. Initially you have P at t equal to 0, then it becomes 2P by 3, then it becomes 2 by 3 square P, then it becomes 2 by 3 cube P, then it becomes 2 by 3 to the power of 4P, then you have 2 by 3 to the power of 5P. This is at the end of 5th year, and at the end of 6th year you have 2 by 3 to the power of 6. Okay, so that is the basic idea which we have to follow in this question. Alright, so this is year 0 and this is year 6. Moving on to the next question. This question is actually one level up of this previous question. In this question the idea is the same like previous, but the calculation is, you know, a bit too much of a pain. Okay, so now we have third question which says a boy plays with the ball and he drops it from a height of 1.5 meter. Okay, so let me draw it. We have the ground here and you are dropping the ball from a height of 1.5 meter. Now it says that when it bounces back, it attains a height of 4/5 of the previous height. So now suppose after the first fall here, first time touching the ground, it will definitely bounce back and it will bounce back to the position which is 4/5 of the previous height. So let us assume this is that particular height. It will bounce back to this particular height. This height will be how much? 4/5 into 1.5 meter. When you simplify things out, you will get the answer as 1.2 meter. So it will bounce back to a height of 1.2 meter. The question further says that the ball does not bounce further if previous height is less than 50 centimeters. So this is the criteria that when the ball will stop. So that is the criteria. So question says that what is the number of times the ball hits the ground before it stops bouncing. So we have to just find out the idea, find out the way in which the ball is bouncing. So initially you drop it from 1.5, it hits the ground for the first time, then it bounces back to a height of 1.2 meter. After it again falls down. It hits the ground for the second time and again it will bounce back. This time it will bounce back to the height of 4/5 of the previous. So the previous height was this. The new height will be simply 4/5 into 4/5 of the initial height 1.5. Okay. So this height is 4/5 of the first. This height will be further 4/5 of 4/5 of the first, and that will be simply, if you calculate the value comes out to be around how much? 0.96 meter. So now it will bounce back to the height of 0.96 meter or 96 centimeter, right? Then the ball will again touch the ground, hit the ground for the third time and again bounce back. This time let's say it bounce back again to this particular height. So what will that height be? That height will simply be, let me use a different pen now, 4/5 into 4/5 into 4/5 into 1.5, that is basically 4/5 cube into 1.5, and when you calculate the value comes out to be 0.768 meter. Okay, this will be the height to which it will bounce back. Even now you can see this height 0.768 meter or 76.8 centimeter is greater than the threshold of 50 centimeters, so it will again bounce back when it falls. So now this time the ball again hits the ground, it hits the ground for the fourth time and again it bounces back, and now it bounces back to this height, right? What this height is going to be? This height is going to be, as you know, 4/5 to the power of 4 into 1.5, and the value comes out to be some nasty values there. That will be 0.6144 meter, which you can read as nothing but 61.44 centimeter. Even now it is greater than 50, so it will again have a chance of bouncing back. So now this time it hits the ground again for the fifth time and again bounces back. And now the last time it will reach at this height. Here you can see when it will reach this height, the new height will be simply 4/5 to the power of 5 into 1.5. When you simplify and calculate all this value, you will get the final answer as 0.49 and something meters, which is 49 and something centimeters, definitely less than the 50 centimeter bar which is given to bounce back. So definitely after hitting this particular height, this will not bounce back and it will just, keep rolling on the ground. So as you can see here, let me use a red color for representing this. So it will keep just bouncing and rolling on. It will not bounce back, it will just roll on ahead. So this is the way the trajectory of ball will be like. Will fall from here, hit the ground first time, then second, then third, then fourth, then fifth, and then it will just roll ahead. So what is the number of times it is hitting the ground before it starts, before it stops bouncing is 1, 2, 3, 4 and 5, that is 5 times. Okay, so this question was bad in terms of calculation only. If the values would have been good, some questions are there. Generally CSAT has the habit of giving you calculations which are not tedious, but this particular calculation is quite tedious. Otherwise the concept is not that difficult. Okay, so we had this question. Now we'll move on to the next question, which involves the concept of simple interest and compound interest. So let us have a brief discussion about it. So you must know the idea of interest. Interest is the amount you earn as profit when you lend money, right? So here we have the idea of simple interest, and the formula is nothing but P into R into T by 100. So this is simple interest. Here P is nothing but the principal amount, the amount you give as a loan. Then T is nothing but the time period, and R is nothing but the rate of interest at which you are lending to the other guy. This is the basic idea of simple interest. Now let us talk about compound interest. So the compound interest is actually the real behavior of money, the way how money actually behaves. So money has the nature of compounding. So in compound interest, what happens, that suppose you are lending some money for the first year, you will get interest for it. Then for the second year, the interest earned in the first year will add up to the principal, and in the second year now you will earn interest for a bigger amount, which is the previous principal plus the interest of the first year. On this total amount now you will get the interest, and the money will keep on compounding. So after suppose 10 years you have earned interest, for the 11th year you will earn an interest on the total principal plus the interest you earned in 10 years. So in that way, that is the idea of compound interest. And I know it's a bit complicated, but here I am just giving you a basic introduction so that we are able to solve the single question, one single question ever which has been asked from this topic. So we have CI, and the formula is simply P 1 plus R by 100 to the power of t. This is the basic formula. It is not for the compound interest actually. This is for the compounded amount, total compounded amount. Suppose you lend this much amount, in the next year you will earn interest on it, it will get added up to the principal or the total amount, it will further keep on compounding. So the compounding amount, total amount is given as by this formula. Okay, so these are the basics, and now we have a question. The question is not that easy, let me tell you. So the question says a person bought a refrigerator of this much amount with this much loan, 12.5 interest rate. At the end of the first year he paid this much amount. At the end of the second year he paid this much amount, and so how much he will have to pay at the end of the third year to clear the debt. So the question or the story goes like this, that there is a person who is going to some shopping mall, purchasing a refrigerator on EMIs, and he is taking a loan of, as you can see, for a period of 3 years. Okay, so at the end of first year he will pay some amount, at the end of second year he will repay some amount, and at the end of third year he will repay some amount. So let me just represent all that information in the form of a nice diagram. Suppose this is the timeline, this is year 0, this is the year 1, this is the year 2, and this is the year 3. Now the person takes a loan of rupees so much. Let's say he is taking, what is the amount of the loan? Just a minute. So the amount of the loan is 22800 rupees. This is the loan amount he is taking. This is nothing but the principal. And now he is trying to repay the loan in some installments. So suppose in the after the end of first year, he is paying an installment of the whatever be the amount. I think it is 8650 rupees. Then at the end of second year, he is paying the installment of rupees 9125. And then at the end of third year, he is asking how much amount he should pay. So let us assume he is paying rupees X. So how much amount he should pay so that this loan is paid completely. So the basic idea in this particular question is I have represented it by a diagram. Now you must know one thing. You are taking this loan for a period of 3 years. So after 3 years, this amount of principal will be compounded for 3 years. And after 3 years, this P will be simply, this P will become P into 1 plus R by 100 to the power of T. Here the time period is equal to 3, so you get this amount. Okay. Simply, this is about the principal. This is the basic idea of compound interest. But the interesting catch here is the 2 installments you are paying will also earn some interest. So let me show that to you. So now as you can see, you paid this amount 8650 at the end of first year. So it will get some interest for this period of time, for this period of 2 years. So this amount, let us assume it to be 8650, whatever it is. This 8650 will earn an interest for how much period? 1 plus R by 100, the same thing will be there. But the time period is now 2 years, so we just write. Similarly, this amount is actually earning an interest for a period of 1 year, as you can see. So this amount 9125 will be getting interest for 1 plus R by 100 for a period of 1 year. What about this last amount X you are paying? Since you have paid this amount X just now, very freshly paid, right? So the amount will not earn any interest and it will be simply added as x. So the basic idea of the question goes like this. Instead of writing P, let me write, sorry, it just went, all of it just went. So the basic idea I was representing was this, that 22800, the original principal amount, 1 plus r by 100 to the power of 3. This will be equal to the individual installments you are paying. That was, first we were talking about how much first term was 8650 being compounded for a period of 2 years. Then we had 9125 being compounded for a period of 1 year, and then we had the last amount of installment, that was x. This is the way we are going to talk things. This is what I had written previously on the slide, which got flickered away. But here you can see this total amount of loan will be paid by 3 installments. On the first installment you will get an interest for 2 years, on second installment you will get an interest for 1 year, and finally you will get no interest on the last installment. That is the way in which you have to solve the whole question. So let me come back to the final stage now. Here, as you were told that R is equal to 12.5%. So this part, which is common in all, which is nothing but 1 plus R by 100 is simply equal to 1 plus 12.5 by 100, and this overall term will be nothing but 1.125. Okay, so all these terms are 1.125. Here it is in cube. Here the term 1.125 is in square. Here it is simply to the power of 1, and here there is no power at all. So simply this is the way in which we will be calculating. So the final equation which you have to solve here will be of the format 22800 into, and now one more good advice which will be helpful. You can rewrite, you have 1.125 which can be written as 1125 by 100. When you cancel out both of them by a factor of 125, on the top you will get a 9, on the bottom you will get a 8. So this value can be also simplified as 9 by 8, make the things easy for you for calculating. Here we have 9 by 8 to the power of 3 is equal to 8650 into 9 by 8 to the power of 2 plus you will have 9125 into 9 by 8 to the power of 1 and plus x. This is the value of x which you have to find, and I know the calculation is a bit nasty, but after all the long and tough calculation, you know, you will get the value of x as 11250 rupees. Okay, so this is the final, that is option number D here is going to be the correct option. So this was the only question which has been asked from the topic of SI and CI, and I admit this is one of the toughest question you can find from the particular topic. Okay, so now we'll move on further to the next types of question which are miscellaneous in nature. That is, further in the miscellaneous category, they are more miscellaneous than ever. Okay, so now as you can see, we have the fifth question, and let us try solving it. So we have a frog which tries to come out of a dried well which is 4.5 meters deep with slippery walls. Okay, so let us try to make a diagram which will make things clear for us. So suppose this is the wall. The wall is 4.5 meters deep, and at the bottom here we have a frog. Let us draw the frog with this red color. So we have this frog. Okay, let's call it F. So what does the frog do? So every time the frog jumps 30 centimeter, so this frog is jumping to the height of 30 centimeter, but then it slides down 15 centimeter because the walls are slippery, so it comes down to again 15 centimeters. So overall we can say once he makes a jump and he actually slips down, the overall movement he is having, which will be 30 centimeter minus 15 centimeter, that is equal to 15 centimeter. So overall you can say he jumps once, okay, and then he slips down. So ultimate displacement he is having in the vertical direction, it is going to be only 15 centimeter at a time, right, in one jump. And what he is trying to do, he is trying to come out of the well, so we have to find the number of times he will have to jump actually from here. So that is the question. So here you have to just find out in how many jumps he will actually come out of the well, which is 4.5 meter or 450 centimeter deep. So let us convert all the things in centimeter in one unit. So the frog in one jump completes 15 centimeter of height. So in 10 jumps, he will be able to cover a height of 15 into 10, that is 150 centimeter. As you can see, it is still less than 450, so he need more number of jumps. So let's say he is making now 20 jumps. The height he will reach up to will be 20 into 15, that is 300 centimeter, still less than 450. So now let us talk about, let's say he is making 25 jumps. So in 25 jumps, he will be able to reach a height of 25 into 15. I think that comes out to be 375 centimeter. So we are getting close and close to the height which he needs to actually jump out of, which is 450 centimeter. So we will now try for values which are somewhat having a smaller gap. So instead of 30, let us try with just 28. So let us take 28 jumps. So in case of 28 jumps, the height covered will be 28 into 15, and I think the value comes out to be 420 centimeters. So as you can see, it is now very close to the end. He is this position 420 centimeter after making overall, let's say he made 28 jumps and he reached at the height of 420 centimeter, right? Now you have to pay attention at this part. Now since he is at 420 centimeter and he in the first time jumps a height of 30 centimeter, so in just one jump he will be able to come out of the well and reach a height of 450 centimeter. Okay, in this case he will not slip down because he will just escape from the well. So the number of jumps required to come out of the well will be, so let us call the number to be n. So we need 28 jumps. In each 28 jumps he will go up 30 and slide down by 15. So net displacement is 15. So overall in 28 jumps he reaches a height of 420. But as he reaches a height of 420, he will make just one jump and cross this 450 barrier with a leap of 30 centimeter and he will be out of the well. Okay. So we have total number of jumps as 28 plus 1 in this final jump he will be out. So total 29 jumps will be required to get out of the well. So we have option number B as 29. So here as you can see, there is no approach, no equation making. The question is quite random, right? And you have to just be aware that in the last jump he will not slide down again. So this is something, if you assume that he will slide down, what will happen? You will get the wrong answer of 30. That is not the case. Okay, so be careful in this particular question, in this very part. Okay, that in the last one he will just directly jump out of the well and not slip down. So that is the idea of question number 5. We'll move on to the further question, that is question number 6 now. This also, as you can see, is quite a random question. It says, suppose you have sufficient amount of rupees of currency in 3 denominations rupees 1, rupees 10 and rupees 50. So you have a lot of number of coins or rupees or notes, whatever you have in these three denominations, which is rupees 1, rupees 10 and rupees 50. So it says, in how many different ways can you pay a bill of rupees 107? So in how many ways you can pay a bill of rupees 107? So this question slightly gives you the feel of permutation and combination, but it is not that related to the topic. It is somewhat very random in its approach. So let me show you the approach. What we will do is that we will take three cases. So case 1, case 2, and we have another case, case 3. We'll talk about the three cases one after the another. So in the first case we have that we are having 250 rupees notes for payment. So now you are paying using 250 rupee notes. So you have 2 times 50. This makes the amount to be 100. Now in order to make it 107, you just need 7 1 rupee coins. So you have 7, sorry, not multiplication, plus you have 7 into 1 rupee coins. So this 50 rupee notes, 2 of them you are taking at this time in the first case, and then you are taking the remaining 1 rupee coins, 7 of them, and overall the amount will be 107. So this is only one way of paying the bill. Okay, so if you are taking 2 50 rupee notes and the remaining are simply 1 rupee coins, you will have only one way of making the payment, which is 2 50 rupee notes and 7 1 rupee coins. Now let us take the case in which you are taking only 1 50 rupee note. So now you are taking 1 50 rupee notes, correct? But then you will have various options now. Once you are taking this much amount, you can take, now just pay attention, you can take either 5 10 rupee notes or 5 10 rupee coins, and remaining will be 7 1 rupee coins. This will also make the amount to be 107. Okay, so you have 1 note of 50, 5 notes of 10, that will make amount of 50, overall 100 plus 7. What else you can do? Instead of having 5 coins of 10, you can also have 4 coins of 10, and now the amount paid by these 1 rupee coins will be 17 coins you will take of the denomination 1 rupee. So now again the sum is coming out to be 107. So you have 50 plus 40, which is 90, plus 17, again 107. Also what you can do is that you can take the amount of 10 rupee coins as 3 number and pay the remaining amount. So you will need 27 1 rupee coins. Again the sum will come out to be 107. Similarly, you can also have the case of, let's say you take 2 10 rupee coins and remaining amount, that is 37 rupees, is paid by 1 rupee coins. Similarly, also you can use only 1 10 rupee coin and the remaining amount of 47 is paid using 1 rupee coins. And the last way would be, you do not take a single ₹10 coin and the remaining amount, which is rupees 57, will be paid using simply 1 rupee coin. So these are the various possible combinations in which you can pay an amount of 107 if you are using only 1 50 rupee note. So we have either remaining amount will be paid by 10 notes, 7 rupees, then 4 notes, here we have 17, 30, 27, now you are having 20, 37, 10, 47, and finally you have no note of 10 rupees or no coin of 10 rupees, and you are paying the rest amount by only 1 rupees coins, which are 57 in number. So as you can see, there are 1, 2, 3, 4, 5 and 6, total 6 ways of paying the money or the amount if you are using only 1 rupees note. Okay, so if we take out the sum, so far we have 1 way plus we have 6 ways. And now let us talk about the case 3, and you can easily guess what case 3 is going to be. Case 3 is going to be the case in which we are not using any 50 rupee note. So let me just clear the space and you will be clear with that also. Okay. So now in the third case we are having no 50 rupee note we are using. So what are the options? Either we can use 10 rupee coins and pay the remaining amount by 7 1 rupee coins. This will also make the amount to be how much? 107. Or what you can do, 9 coins and here you have 17 coins. Or you can have 8 into 10 plus 27 into 1. Or you have 7 coins of 10 and 37 coins of 1. Then you have 6 coins of 10 and 47 coins of 1. Or you can have 5 coins of 10 and 57 coins of 1. What else? Then further you can have 4 coins of 10 and then 67 coins of 1. Then you can have 3 coins of 10 and 77 into 1. As you can see, these will be the further cases. And finally the case will be that you are not using any single 10 rupee coin and the rest of the amount, total amount, will be paid by all 1 rupee coins. So as you can see here, we have a lot of cases and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11 ways in which we can pay an amount of 107 if we are taking no 50 rupee notes and we are using only 10 rupee coins and 1 rupee coins to pay the amount. Okay. So overall, using the case 3, now we have 11 ways. So this was the case 1 when you are using 250 rupee notes. This was the case 2 when you are using 150 rupee notes. And this was the last case in which you are using no 50 rupee notes. And therefore, you have overall 1 plus 6 plus 11, that is 18 ways to pay the amount. So we have option number C as the correct option in this particular case. So here also the question is quite random, but I think if you figure it out, it is not that difficult and you can now attempt similar questions on the same idea. Okay. So now we have the last question of the whole discussion, the last question at all. And so please do not get afraid by looking at these things. Okay. So people are afraid, they just get one question of statistics and they are afraid, okay, we should also study statistics. No, that is not required. So far only one question has been asked in CSAT, that too 5 or 6 years ago. So you need not to actually bother about it. So this question, let me read it for you. If for a sample data, the mean is less than median and which is further less than the mode, then the distribution is symmetric, skewed, neither symmetric nor skewed, or skewed to the left or skewed to the right. These are the 4 options given to you. So let us talk some basics and it will be quite easy for you. So what are the 3 terms? You have the 3 terms mean, median and mode. So mean is the arithmetic mean, the average, right? Median is the middle value of the distribution. And what is mode? Mode is nothing but the value with maximum frequency. Right? This is the basic of mean, median and mode. Now suppose if we have the case where we have this mean is equal to median is equal to mode. So such a distribution is known as normal distribution. Let me draw a graph and you will be clear. And don't bother if you are not able to figure out, only just one question has been asked so far. So we have this distribution. As you can see, it is quite symmetric along this particular axis or line. Here in this line we can see this point. This point is nothing but the mean as well as the median and as well as the mode. So here in this question we can see median is equal to mean is equal to mode. All the three lie on the same point and therefore this distribution will be a symmetric distribution. Okay, right? So this thing is clear that this option number A can be easily eliminated. This distribution is not going to be symmetric at all. Now what the question says, it says mean is less than median is less than mode. So we have mean less than median less than mode. Okay. So let us draw the graph again. Now what is mode? Mode is the quantity which is actually repeated the maximum time. So whatever the peak of the graph is, that will be the mode. So suppose we have this graph. Okay, here the quantity which is repeated maximum is at this point, it is having the maximum value. This is repeated the maximum time. So this quantity is going to be the mode. Let me use blue color to represent that. So this is the mode, the peak of the curve. What about median? Median is the middle value. So median will be somewhere in the middle. Let's use green color to represent it. And so median will be somewhere here. The question says that median is greater than mode. In this example you can see median is actually greater than mode. We have different case. We have median is less than mode. Let us talk about this opposite case first. Here we have median is actually greater than mode. The middle value is greater than the peak value. So this is the mathematical or the value in terms of x coordinate. This median is actually greater than the mode because of this difference. And so we can say that the middle value will be deflected on this side and the overall graph is skewed. As you can see, the pattern is skewed towards the right side. So this is the right hand of mine, and as you can see, otherwise if it would have been symmetrical, it would have been like this, but it is slipping, it is skewing to that side. So this is skewing towards right because here the median, the middle value is greater than the mode. Now let us talk about the case in which our question is framed. So our question says that here we have mode is greater than the median. So let us talk about that case now. So we have mode as the value which is having the maximum repetition. So the peak is the mode. So here we have our peak which is the mode, right? And where is the median? Median will be somewhere here in the middle. This is the median. Okay, so median is nothing but the middle value. Okay, so overall as you can see here the median is less than the mode is having this value greater than the median. Now as you can see, if this distribution would have been a normal distribution, you would have got a curve like this, but now as you can see it is slipping or it is skewing to the left side. This is the left side, guys, so this is skewing to the left. So let us see our options now. The option B says it is skewing to the right. No, it is not the case. because we have median less than the mode, and therefore we have the correct option as skewed to the left. So we have option number D as the correct option in this particular question. So on that note, we have actually completed the whole discussion for CSAT, and this brings us to the end of the journey, which has been important not just for you also but for me also. And we have exhaustively covered whatever topics, whatever questions we can have in CSAT, and I hope all the discussion we had will be very useful to you to cross the 33% barrier. So thank you guys.